Good evening, everybody. My name is Finance. We'll be looking at a topic called density of trust and relative density. Density of trust and relative density. Density has to do with how heavy something is. How heavy something is. Why? Of course, density varies from one substance to another. Density varies from one substance to another. Density varies from one material to another. Our density, mathematically speaking, density is known as mass per unit volume, where this one is represented with rho, and you have your mass and over volume, and the units can be in gram per cm cube and or kilogram per meter cube. So units of density is kilogram per meter cube or gram per cm cube. The relationship between these units is just a factor of 1000. If you want to convert from gram per cm cube to kilogram per meter cube, you multiply it by 1000. So for instance, let's say e.g. 5 gram per cm cube to kilogram per meter cube. Simply write solution 5 gram per cm cube to kilogram per meter cube. That will just be times 1000, and automatically it's going to give you 5000 kilogram per meter cube. And on the other hand, if you want to convert from kilogram to kilogram per meter cube to gram per cm cube, you divide it by 1000. That's density. So the next topic we'll be looking at is upthrust. And when you talk about upthrust has to do with loss of weight. Upthrust is loss of weight. And by formula, it is rho Vg, where the rho here is equal to density, and like I've said earlier, that the unit is gram per cm cube or kilogram per meter cube. Your V here you have to be very, very careful, because your VOI here actually represents the volume of the object in mass in a fluid. The higher the volume, the higher the upthrust, and the lower the volume, the lower the upthrust. So volume of objects in mass, and the G there is acceleration due to gravity. Acceleration due to gravity. Now, another important information that you need to put in mind here is that upthrust actually depends on density of the liquid. It depends on density of the liquid. If the density of the liquid is very high, automatically the upthrust will be very high as well. But if the density is very low, then the upthrust will be very low. We can cite a practical example. Let's say an object is moving from a seawater into fresh water. The density of seawater is higher than that of fresh water. So while the object is inside seawater, the upthrust will be higher than that of when it is in fresh water. So you take proper notice of that. So then upthrust, like I said, it has to do with what? Loss of weight. And finally, we are looking at our relative density. When you talk about relative density means the comparison between two densities, and we often compare the density of a substance with density of water. So relative density is the amount of density of substance with respect to that of water. And density, relative density, unlike density, I said density as the unit gram per cm cube or kilogram per meter cube. Here in density has no unit. So this is a basic difference between relative density and density. It has no unit. Or you can simply say it is dimensionless. Or simply it is dimensionless. So by formula, relative density equal to density of substance over density of water, where S represents substance and that of H2 simply equal to water. So we have come to the end of our today's lecture. We are going to, in the next video, we are going to solve our practical examples, and we are going to make use of the formula I've highlighted in the lecture. In case you have any question, you can follow me in the further videos we'll be uploading or releasing by pressing the subscribe button below and turn on the notification. See you next class.